Hey, friends, let's talk about something that quietly runs the modern world but almost never gets the poetic treatment it deserves: the silicon beneath our screens. CPUs, GPUs, RAM, ARM, emulators. These sound like dry acronyms, but together they're shaping how intelligence is simulated, how worlds are rendered, and how the future of gaming and AI is being rewritten, especially for a country like India. Let me start with GPUs versus CPUs, because this is the heart of modern AI and simulation. Think of a CPU as a brilliant professor sitting alone in a quiet room. It's incredibly smart, excellent at logic, decision making, and handling complex instructions one after another. It thrives on order and sequence. That's why CPUs are perfect for operating systems, spreadsheets, and general purpose tasks. A GPU, on the other hand, is not a professor. It's a stadium full of disciplined workers, all doing simple tasks at the same time. Individually, each worker isn't very clever, but together they can move mountains. AI training and simulations don't need one genius. They need millions of tiny calculations happening simultaneously. Matrix multiplications, pixel shading, neural network weights, these are repetitive, parallel jobs. GPUs eat that for breakfast. That's why AI models train on GPUs. Not because CPUs are weak, but because parallelism beats intelligence when scale explodes. Simulations, whether it's weather models, physics in games, or virtual crowds, are less about what comes next and more about do this everywhere, all at once. GPUs were born for graphics, but graphics themselves are just math repeated millions of times per frame. AI simply hijacked that superpower. Now, all this power immediately runs into a quieter but brutal bottleneck: RAM. RAM is not intelligence, it's working memory. It's the size of your desk, not your brain. And between 2025 to 2026, we're seeing a very real RAM strain across the industry. AI models are getting bigger, textures are getting heavier, operating systems are bloating, browsers are becoming mini operating systems themselves, and suddenly 16 gigabyte doesn't feel luxurious anymore. The problem isn't just demand, it's supply chains, fabrication yield limits, and cost. High bandwidth memory, HBM, for GPUs is being prioritized for data centers and AI labs, which means consumer markets feel the squeeze. When RAM is short, systems don't slow down gracefully, they choke. Swap files, stutters, asset pop in, and training crashes are all symptoms of a desk that's too small for the work being done. And this leads us neatly to architecture, specifically ARM versus x86, x32, and x64. x86 architecture, what most PCs use, is like a heavily evolved industrial machine. It's powerful, backward compatible, and incredibly flexible, but it carries decades of baggage. x32 was constrained by memory limits. x64 broke those chains and became the backbone of modern computing. But power efficiency, not its strongest suit. ARM is different. ARM is a minimalist by philosophy. It does less, but it does it efficiently. Lower power draw, better performance per watt, and designs that scale beautifully from phones to servers. That's why your smartphone can do things today that required a gaming PC 10 years ago. For a long time, gaming stayed away from ARM, not because ARM was weak, but because the ecosystem wasn't ready. Games, engines, middleware, and DRM were all deeply married to x86 assumptions. But that wall is cracking. Steam, very deliberately, is working to make ARM a stable, first class citizen. Proton, translation layers, engine level support, this isn't a side experiment. It's a recognition that the future of computing is heterogeneous. PCs won't be one architecture to rule them all, they'll be flexible, adaptive, and abstraction driven. And this is where things get genuinely exciting. Tools like WinLater, GameHub, and other PC emulators on Android are not party tricks, they are proofs of inevitability. They show that the boundary between PC and mobile is artificial. If you can translate instructions efficiently, manage memory well, and map APIs intelligently, then a game is just code running on silicon. Nothing more sacred than that. Yes, there are compromises today: performance overhead, compatibility issues, thermal limits. But remember, early 3D games once ran at 20 FPS and people still felt wonder. Progress doesn't ask for perfection, it asks for momentum. And when I look at all this from India, I feel something rare in tech discussions: optimism without delusion. India doesn't just consume technology anymore, it adapts it, bends it, and scales it in ways few countries can. ARM makes sense for India. Power efficiency makes sense for India. Mobile first innovation makes sense for India. AI democratized through cheaper hardware makes sense for India. Imagine students training small AI models on local machines. Indie developers building games that run across PC, mobile, and ARM-based handhelds without rewriting everything. Internet cafes replaced by cloud-assisted, low-power gaming hubs. Regional studios telling stories rooted in Indian realities, powered by tools that were once locked behind expensive hardware. GPUs doing the heavy lifting, CPUs orchestrating the logic, RAM trying desperately to keep up, ARM quietly rewriting the rules, and emulation acting as the bridge between generations. This isn't fragmentation. This is evolution. The future of AI and gaming isn't about one machine becoming infinitely powerful. It's about many kinds of machines learning to speak the same language. And for the first time in a long time, that future feels accessible, not distant. So, yes, hey friends, I'm optimistic. Not because technology is perfect, but because it's finally becoming inclusive, flexible, and imaginative. And that's exactly the kind of future India thrives in.